we go. Oh, yeah. Okay, so I'm Dimitri Desmidt. I'm part of the NSBU, so the NSX business unit. And we'll talk today about advanced network services. And there is Max also, but Max today, he lost his voice, so he will do the clapping. So if you rate the people, the content, you rate under my name, and the clapping, you rate under Max. So we'll talk about advanced network services. And just before starting, I just wanted to know who knows NSX first. 60%, 70%. So for the last 30%, I'll try to do some catch up, but yeah, you may miss some bits, and we can talk at the end on the basic missing bits I won't cover here. So the disclaimer is the same everywhere. So what we will talk today is what network and security services we do in NSX, and you'll see that's not so many because actually in the world there are not so many network and security services that do exist to run all your crazy applications. And then I'll focus on 3 advanced services: firewalling, load balancing, and VPN. And I'll do some demos around the line, on the show. And then I'll finish with a quick introduction on what we can do to enhance NSX native capabilities with partners. So, I didn't ask. Who consider himself like a network guy, and who hypervisor guy? So network guy? Wow, at VMworld, yeah. And hypervisor, compute, server guy? Oh, more. So you want to learn the dark side of or you want to take their job, or? Well, so, okay, so for the server guys, if we can do that in an interactive way. So if you have questions, feel free during the show. If there are too many, then okay, we'll do it at the end. But let's try to do it interactive so I understand you understand me. Okay, so network and security services. There are not so many actually if you think about it. You have the L2 switching. So you know 2 servers or 2 VMs. I have a VMware badge, I should say VM. 2 VMs in the same subnet, and they have L2 connectivity. So switching with maybe some services like DHCP, like DNS. Then what other services do the network guy offer? He offers routing. It's to provide connectivity between 2 different subnets. So far, so good. Maybe some NAT, network address translation, if you have private IP addresses. Ooh, that was fast. Maybe some dynamic routing to advertise those subnets to the rest of the world, but it's still routing. Then firewalling. I don't know how to do laser with this fancy one. It's too fancy for me. Then firewalling to secure traffic between subnets. So from the web tier to the app tier, you can do only, I don't know, MySQL. If the guy is a little bit fancy, the network guy or security guy is a little bit fancy, he may do some security between the same subnet. Or if he has the capabilities, it's pretty hard to do, but maybe he's smart or he has the tools to do that. So securing traffic within the same subnet, so the web server to the web server cannot do SSH, for instance. Make sense? So L2, L3, security. Load balancing, it's to share the load among multiple servers. And you can have a load balancer, and I really need a laser. You can have a load balancer in one-arm mode, which means the load balancer is single attached, or you can have a big L3 device at the top that does routing, maybe security on the top of routing to protect communication between tiers, between subnets, And on the top of that, because that box is a magic big box, does also load balancing. So that's what you do, load balancing as well, maybe in your network, and VPN. So to provide L2 or L3 communication from outside, from people working from home or pretending working from home and things like that. And now I have a laser. No. Yes. OK, so this one. And that's pretty much it. So for the server guys, when the network guys talk to you, that's actually the only thing that you offer. So you know now. And what we're trying to do on NSX is to offer those services, network and security services, but in a central manner. So the network guys, I don't know if you went to his cube or office. I mean, he always have like a bunch of SSH stations to his switches and routers, and maybe a browser connected to his firewall he loves, like Checkpoint, Palo Alto Networks, whatever. And maybe some other web UI or SSH connections to the load balancer. So he has plenty of windows to do that. And what we're trying to do is to centralize all of that, so the network guy manage all this in a central manner, which makes his life easier. And on the top of that, we give them, the network guys, tools to deploy all that fancy stuff in one click, because all can be automated. So you can deploy, I don't know, 100 routers with firewalls, with blah, 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 in a fully automated way. Make sense? So that's what NSX is in a 5 minutes, 5-10 minutes introduction. That's for the 70% who knew NSX, that's what you understood with the offer? Yeah, OK. So now I'll skip the basic network services, and I'll focus only on the advanced ones with this one, with firewalling, load balancing, and VPN. So let's start with firewalling. So actually, the way we do firewalling is what we call, first of all, we do not call that a firewall. We call that a distributed firewall. And why? Because you do your configuration from a central place where you say my web servers can do blah blah to my app servers can do blah blah to my database servers. From outside, nobody can talk to my database servers. So you do all those rules sorry, in a central manner. However, it is pushed not to a box. I mean, VMware still doesn't do boxes anyway, but it's not pushed to a VM. It's pushed to all the hypervisors in the kernel. So it's not a VM, but it's in the kernel. Those rules are everywhere on all the ESX. And when I say those rules are from web to app tier, you can do blah blah. From app tier to DB, you can do blah blah. If that ESX has only the VM web 1, it will have the rules that apply only to that VM and not your thousands and thousands of rules you may have. So your rules are centrally, but pushed smartly to each ESX. Make sense? So far, so good? So what does that give you? That gives you an amazing performance. Because and we'll talk about performance in a few slides. If you ask me how much can push my firewall, I cannot give you a number because I don't know how many ESXi you have. More ESXi you have in your vCenter, more firewall capacity you have. Make sense? And also it gives you some cool stuff your network guys couldn't do before or had big troubles to offer, is security between the same subnet, between the same L2. Before, when you're on a VLAN or in a subnet, everybody can talk to everybody on that subnet. Or I don't know, do you offer security in the same subnet or not? Or it's like open bar? Sorry? Special cases? and how do you make that security from IP 10.10.10.11 to IP 10.10.10.12? On the switch itself, you do some ACL, and if you have not a physical server, but a VM, and that VM moves, then you're out of luck. Okay. Which is fine. I mean, you don't have to have VMs everywhere. But, I mean, if you have VMs and you're at VMworld, then usually it's pretty hard to do. And now we help you to offer service for your application guys that are a little bit paranoid or whatever. And you can have your bonus at the end of the year. So I'll explain how we do that very briefly. If you want to know under the cover how we do that, we can talk about that at the end of the session, or there is a dedicated session on that as well. But we offer those services. So it's crazy performance because it scales out with the number of ESX, and also security within the same L2. And you may have heard about this buzzword, micro-segmentation, and actually this is offered thanks to this capacity, which is the ability to filter traffic even within the same subnet. Because the firewall is actually on the VM NIC and not on the, oops, this one, not on the router. Okay, then lots of vendors, so here not a lot of vendors do that, or actually pretty much nobody. Here it's, okay, it's like we do too. So you can use MAC addresses, you can use IP addresses, but you don't have to. You can use also names. The beauty is instead of using basic names, you can use actually anything, any vCenter container. So you can say, like in this example, the web tier, oops, that one. The web tier can do XYZ, can do HTTP, HTTPS to the app tier. So you don't use IP addresses, you don't use subnet, you use that container. But you could use also VM names. You could use any vCenter object to build your rules. So that's for the ease of use. Now on the port numbers, you don't have to remember, okay, HTTP is TCP port 80, SSH is port 22, DNS is UDP or TCP sometimes 53. You can use English or, yeah, English names for the application, so that makes, again, your life easier. Also, we do support, oh, by the way, we do support a bunch of ALGs. So, you know, some applications use dynamic port numbers. And for that, the firewall needs to understand the application to learn the dynamic port number selected by the application on the fly. And we support a bunch of those. I finished with this one, but it's actually maybe the most powerful one. And it's something unique you have within NSX, is this construct. And we call that service composer. It's maybe not the best name we could come with, because it doesn't mean anything to people. But what is it? It's the ability to create security policies. So what is a security policy? It's, you say, you can do, I don't know, web, HTTP, HTTPS, but not SSH, or, I mean, the kind of applications you want to allow and deny. You don't say where they are applied. You just say the kind of applications you allow and deny. And then you create security groups where you put people in that. So logical switches, VMs, any vCenter object. And on that security group, you apply one or more security policies. Okay? And this allows you to have security in place in a new, easy manner. Let me give you an example. And yeah, that will give you agility and service compliance. And I'll give you an example in a minute, and I have a demo with that, actually. Just before the demo, let's talk about performance. So agree, I mean, it's running on ESX, that distributed firewall, but it's not on a VM, it's running on kernel. And so you have a process running on each ESX. And because it's in the kernel, it's actually pretty powerful. So this test is something I recommend you do. It's easy to do. You just need 2 ESXs. And what you do is just plug it on any switch you love with 10 gig interfaces. And you double connect each. So you virtually have a NIC bonding. You have a 20 gig NIC on each ESX. So pretty easy to do. And then you install 2 VMs, Ubuntu, whatever. And VM1 will talk to VM3, VM2 will talk to VM4. You use the tool you want, iPerf, NetPerf, whatever, something that will just push as much as you can. And you do the test without firewalling and with firewalling on, so you can compare apple to apple. You use the same tool, the same ESX, the same everything. You just turn on, off the firewalling feature. And you'll see we can do on NSX with switching, roughly 20 gig of traffic without firewalling. And you turn on firewalling, or firewalling on, and you almost do also the 20 gig. There is a 3% drop, but OK, I'll have my marketing hat now. So you can saturate a 20 gig NIC as well. OK, I agree there is a little delta, but it's pretty negligible. OK? And that's per ESX. So if you have 2 ESXs, or 3, or 4, or 10, now I don't do 20 gig, I do 200 gig firewalling with 10 ESX. 100 ESX, it's not that hard. OK, that's the afternoon. But that's a lot. OK? Okay. So performance is really something that you should not be, and we are not scared of, because that's one of the areas where we also shine. So a demo I will run, it's, I don't say you have this, but just to, or that need, is just to show the power of what you could build. So let's say you have a DMZ with some Windows servers and some Linux servers, and you have a policy where the Windows servers are allowed to talk to the, oops, maybe I've been a little bit fast. The Windows servers are allowed to get patches from the Windows update servers. So you have the list of IP addresses of the Windows update servers, and those guys are allowed to go on HTTP and HTTPS to download the patches, but those guys are not. However, the Linux guys are allowed to go to the Linux update servers where the Windows are not. So you could do that today, I'm sure, but you will have to have a spreadsheet to say, OK, those servers are Windows, and I put them in the group that can go to those IP addresses, and those Windows are Linux, and they can go there. But we can offer that in a much nicer way and dynamic way. If, I don't know, 6 months from now, there is a developer that deploys a new Linux servers, automatically with no human intervention, that server will be in the group allowed to go to the Linux servers. So how do you do that? It's actually pretty simple. So for the 30% who didn't see NSX ever, when you install NSX in vCenter, you have this new shiny icon. It's a plugin. And this allows you from vCenter to go inside NSX and configure NSX. So you configure NSX through vCenter, actually. And so to do this example, you just go on NSX, you create IP sets of, so IP list of Windows servers and Linux servers. So you have them in this IP set. So NSX knows about those servers. And then under Service Composer, where you have the dynamic security in place, you create a policy, And the policy for Windows, the security policy Windows, will be anybody in that group. I don't tell you what is in the group yet, but everybody in that group can talk to the Windows servers. So I don't have to put IP addresses. I could, but I prefer to use containers. And I can do HTTP, HTTPS on that. And for the Linux, under security policy, I do the same. Anybody that will use that security policy will be allowed to go to the Linux servers and do HTTP, because on Ubuntu it's done on HTTP, on Windows it's HTTP, HTTPS. That's how it works. And then the groups. So under groups, I will create a group Windows, VM Windows, and on that group I will have dynamic membership. So who will be on that group? I don't want to say this VM, that VM, that VM. I could do that. But what I will do is something more powerful, is I will say all the VMs with an OS, operating system Windows, will be in that group. And vCenter knows that. So vCenter will tell NSX, those VMs are Windows, and NSX will put them in that group. So I don't have to put manually the VMs. I could, but I'm just lazy. Okay? And same thing for the Linux. So vCenter knows the operating system, tells NSX, and NSX will put them. And for the Linux, I put the Linux security profile I created before. And for the Windows, same thing. For the Windows, I apply the security policy, sorry, not profile, security policy, Windows. So anybody in that group will have those roles automatically. And in this UI, you know, VMware will love to give you billions of ways to see the same thing. So one way to see who is in that group is here. You go under the virtual machines, and you can see now, those VMs are in that group, which means those VMs have those security in place. So that's one way to see it. So those VMs have this security policy in place. So that's one way to see it. Or you can see it under firewall as well. It's another way of saying it, and then you seeing it, and then you choose the one you like better, where you can see the Windows VMs can talk to the Windows servers on HTTP, HTTPS. And if you want to know who are now the Windows VM, I have two, and who are now the Linux VMs, I have two. Okay? And now they can talk, and you're happy. What's going on now is I will clone a new VM, an existing Linux VM, or I could create a new VM, but I decided to clone a Linux VM. So I clone it. And so now I will have another VM Linux. And once that VM Linux will be in vCenter, vCenter will update NSX about that new VM, so NSX knows about it, and vCenter will tell NSX that VM is Linux. And me, let's say I'm the NSX guy, so okay, it's cloning, it's vCenter stuff, you've been doing that for ages, so let's move forward. It takes time, my disk is slow. But I don't touch anything on the NSX. I have my web VM 7, which is Linux. I go on NSX. I did not touch anything on NSX. And automatically, in the Linux group, I have now the web 7. And that VM has automatically access to the Linux servers because of that rule, but not the Windows servers because of the other rule. Make sense? So, long story short, you have a deeper dive if you want. But on that section, long story short, you can still do, if you're Mr. Security in your company, you can still do security like you've been doing, most likely, and you create your rules using IP addresses and subnet and put them in the right order you love and blah, blah, and apply, and it does a job. Nothing changed. You just have a new UI and you can do some smarter stuff, not smarter, but faster stuff using vCenter objects. So your life doesn't change much, maybe it goes a little bit faster. But if you want to change, you can also, we don't force you to do that, but you could play with security profiles and get your rules automatically applied to the new applications coming and the new VMs coming. And you don't have to show up and you can go to the swimming pool. Okay? No question on firewalling? No? Yeah. Just the mic is coming. I'm getting old.
Is there a way to resolve an FQDN to an IP address dynamically? For example, Windows Update Service is a typical example where an FQDN like Windows Update Microsoft.com resolves to something like an Akamai CDN, or Google API is another example, or also the Apple Push services. A couple of typical old style firewall vendors have policies in place or address book options in place to make such things. Is there also something in NSX?
So is your question about if you have Windows VMs and you want the patches to be all automatically?
Well, it's a general one. You have to create a firewall rule which says a VM should have access to www.google.com. Oh, you want www.google.com is with every request a different.
Okay, I hear you. Okay, the question is you want to make a rule based on a DNS name and not on IP addresses. No, we don't have that. So today you'll have to play with the IP sets, as I've done, and yourself, which is what I actually did to get the IP addresses. I did an NS lookup to know what are all the IP addresses for microsoftupdate.microsoft.com, or it was something like that. I Googled it. And they have 3 IP addresses, as you've seen. If in 6 months or 5 months from now they have another one, you'll have to update that. Yeah, you still have, for the IP set, you still have to do that manually. Okay? Now, you could be a geek, and you could have a script, which is not provided by VMware, but a script that does that, and make an API call to NSX to update the list. But you have to be a geek. Oh, okay, so you're a geek. Okay, so it can be automated. Yeah.
I have a question. I understand that all the service depends on the vCenter server. What's happening if the vCenter server goes down? Maybe another question, if I see that you recognize all the operating systems.
Yeah.
And what kind of operating systems that you can, Windows,
yeah.
Maybe another one.
So the question is, what happens if vCenter goes down? So if vCenter goes down, vCenter will not be able to tell NSX about the new stuff, but everything you have in place will still work. Now let's give so you don't want vCenter down. Let's start with this. Now I don't know if it's recorded, so I cannot say that, but bad stuff happens. I didn't want to say bad stuff, but sometimes bad stuff happens. And what happens in that use case? Everything you have in place, all the rules you have in place will remain. Now, let's say during the period of time where your vCenter is down, you have a new VM. I guess you don't have a new VM because vCenter is down, but let's say you have a guy that will go on ESX directly and do the VM, then vCenter will not be able to tell NSX about that new VM because your vCenter is down. So then nobody will talk to that VM and you won't be happy. But at least we don't break the existing stuff. Make sense? Just wait for the mic.
I understand that the configuration of all the firewalls and rules are on databases. I don't know if it's sure.
Yeah.
Is on the vCenter server the same database, or is another?
No, we have our own on NSX.
Oh, okay.
Yeah. Okay, so long story short, vCenter goes down. I don't like that, so fix it. But however, everything you have in place still works, and the rules are in place, and the security is still in place, and the routing is in place, the switching is in place, the VPN is in place, nothing changed. Okay? Now, if you want to deploy a new application, your vCenter is dead, so your phone will still ring. Okay? Load balancing. Okay, so we support 2 modes of load balancing. We support the one-arm and the inline. Okay? Yeah, I did jump. Okay, sorry. Too much coffee. So typical load balancing integration, nothing fancy. It's what you do with your beloved load balancers, F5, Citrix, A10 networks. I don't know what else. Radware. So we support the same 2 modes, so perfect. So it gives you flexibility. Inside NSX, natively, we load balance layer 4, TCP, UDP, layer 7, HTTP, HTTPS. We have an ALG for FTP. On HTTPS, we can do some cool stuff like I come on HTTPS to the load balancer and I talk on HTTP to the servers. So things like that. I mean, again, nothing fancy. Load balancers have been doing that for ages. But we do that also natively. We have different kind of load balancing methods. We have different kind of health check, different kind of persistence. We can limit the number of connections to the VIP per second, total, same on the servers, stats. We can do some funky stuff on layer 7 for HTTP, HTTPS, like, I don't know, if the request comes with /private, you're not authorized to access the server if it comes from outside, those kind of stuff. Okay? It's not as rich as iRules on F5, but it's pretty decent on HTTP, HTTPS.
What is about PC over IP?
The question is, what is about PC over IP? So PC over IP, we can, it's for, yeah, I guess it's for your VDI stuff. So you have multiple ways to configure your view on your VMware. And PC over IP is using UDP, so we can also load balance that. That said, what you have usually in your view, and we'll have to talk one-on-one what you have, but what people usually have, you load balance on HTTPS on your, how do we call that? Connection servers or something like that? Help me. I forgot, the view connection manager servers? The view? Connection servers, I was right. So you come on HTTPS, you reach a VIP, we load balance your connection servers. The connection servers, if you have the right credential, blah, blah, they will give you an IP address to your PC to go to, and you go straight to your VM. So that connection PC over IP is usually not load balanced. You go straight from there to there. What is load balance is the authentication thing. And if you use a security server, that's the same. You go on your connection servers with your credentials. The connection servers will tell you, go to that security proxy, and you go to that security proxy, and this guy will proxy and go to the server. But that connection is not load balanced. What is load balanced is the HTTPS there. Make sense? Anyway, long story short, it works. And depending on your configuration you have, the configuration, depending on your view configuration you have to do a specific configuration on the load balancer, on us. Okay? Make sense? Scale.
Question?
Yeah, sorry.
Okay, let's say that I have our firewall guy who doesn't want to give up on layer 3. Can I still use this loop balancing feature?
So if you have a colleague who, I mean, if you're in silos and you're the network guy and there is a colleague of you who is a security guy and he doesn't like you, and there is another guy doing the hypervisor and doesn't like you either. I mean, first, maybe, but anyway, so that happens. What you can do, because you don't like him either, what you can do is on your load balancer, so if this is centralized and you want to do this, I mean, and let's say this device is managed by your colleague you don't like, and then it won't give you, it won't configure that device with load balancing. So you don't want to talk to him. What you do is you go in that mode. And in that case, he's doing the L3 and the firewalling stuff, and you do the load balancer in one arm mode, so you still don't have to talk to him. Okay? Or you pay him a beer and you do load balancing here. It's up to you. This one. Okay, scale. So like any load balancer, doing physical boxes, the real ones, or VMs, it's easier to do layer 4 load balancing because you stop at layer 4. That's obvious. And so that's the same for us. If you ask me to do layer 4 load balancing, I will do it at much higher scale performance than layer 7. So layer 4, we almost saturate a 10 gig NIC out of each load balancer. And you may have or you most likely have multiple load balancers. So this number is per load balancer. If I do HTTP instead of TCP, then I need to look at the request, I need to look at the response, so you ask me to do more stuff, and I won't complain, but of course I go a little bit lower in terms of scale. And if on the top of that you ask me to terminate SSL, so people come on HTTPS to me and I talk to the servers on HTTP, then you ask me to go on layer 4 and layer 7 and SSL, so I still don't complain, but of course, there is an impact on the scale I can have. But it's still decent. I mean, if you look at that, I mean, 2 gig, I don't say 100% of our customers are happy with that number, but 90 plus of customers don't have those numbers anyway for their applications. Okay? Make sense? You agree? You disagree? Yeah, question?
On these top performance values, what do you expect the overhead to be on the ESX server itself?
The ESX host will have that load balancer VM. So that load balancer VM will be hot. And now that load balancer VM has this much CPU, this much RAM. I mean, if it's throughput, the RAM, I don't care. But that's the CPU that will turn hot. So my question is, it's true for that, but it's true for anything actually on ESX. How many VMs do you have? And on that ESX that has that load balancer VM, do you have also plenty of other VMs turning hot? And then you have DRS, and it will move the VM to another lazy ESX doing nothing. Or you don't have DRS, and your ESX is hot as well. Okay? So it's nothing to do with this. It's just, I mean, if it's too many VMs doing too many things, then yeah, buy a server. Okay? All good? Okay. No, that one. Okay, so a quick demo. So actually, I'll skip that one because you had too many questions, and I won't have time to go up to the end. But I can show it to you. I mean, if you're the Mr. Load Balancer guy, I mean, you've done that zillions of times, and now you'll do it on NSX, but same thing. You come on HTTPS, and this guy will remove. So that's the case where you're friend with your L3 guy. Otherwise, you do it in one-arm mode. So this guy does the routing plus the load balancing. And doing the load balancing, it will remove HTTPS and talk HTTP there. And the configuration is blah, blah. You can download that, and you can see the configuration. Or you read the manual. This one is more, I like it better because it shows the power of the edge and the advanced capabilities of the load balancing on the edge. Edge is that device doing advanced services. So let's say you run out of public IP addresses and you have 3 applications. So you have app1.acme.com, which is the VIP1, and you have app2, which is also the VIP1, and app3, which is also the VIP1. So everybody will come to VIP1. But if people go ask for app1, you want the load balancer, NSX, to use those 2 servers. If you go to If you go to app 2, you want to use those servers. If you go to, or if the client asks for app 3, you want to use those servers. Make sense? Which means the load balancer needs to look at the layer 7, the host, to make the decision to go here or there. Okay? So how do you do that? Okay, so you go under NSX, and under NSX you go on your load balancer, so edge, and you see on the edge you have a load balancer section. You create an application profile. The application profile is, I don't care about persistence, I don't care about adding any header, so just the default one is just good for that example. If you want persistence, then you configure persistence. You do some health check. So for application 1, for the servers in application 1, you want to do a get slash with the host app1.xyz.com. So that each server 1 and 2 will get that page. You could do something fancy, ask another page, and check if the content reply is blah, blah. Okay? And then you create your pools. So your pool number 1 is with server 1 and 2. The pool number 2, or 12, is 3 and 4, and 13 is 5 and 6. And I use a different health check for each pool. Okay? So pretty straightforward. It's the same on all load balancers. So if you know load balancers, you won't be lost. Now I created an application rule to decide, hey, if it's app 1, go here. If it's app 2, go here. If it's app 3, go here. How do I do that? We use HA proxy syntax. So if you know HA proxy, you won't be lost. If you do not know HA proxy, read the user guide. So what do we do here? Or what do I do here? I create an ACL checking for the host app1.xyz.com. And if it's app1.xyz.com in the request, then I match the ACL host app1. If it's app2, I match the ACL host app2 and blah, blah. And if the ACL match host app1 matches, I go to the backend pool app1. If the ACL app2 matches, I go to the pool app2. And if it's matching the ACL app3, I go to the pool. That was an easy one. Okay. App3. And if it's matching nothing, I just use the default pool I have configured on the VIP. Too slow, too fast, boring? No? Okay, I'm paid to go up to the end. Okay, and then I create my VIP, and I use the pool app1 as default. I use the HTTP profile where I have no persistence, nothing, and I apply the application rule. Make sense? So pretty straightforward. I don't say no other load balancers cannot do it. I just say we can do it too.
Do you have a view?
Oh, just yeah.
Do you have the view of the backend or front end?
Do you have the view of the backend or front end? The question is, do you see?
HA proxy?
Yeah, we have the same concept. Yes, correct. I mean, at the end, behind it's HA proxy. So if you know HA proxy, you won't be lost. And then if you test, I mean, you go on app 1, you go on server 1 and 2, you go on app 2, and yeah, that's a very fancy browser I'm using. You go to 3 and 4, and if you go to app 3, it's a specific page I created, a very complex one, that gives you the server IP address. You go there, okay? Okay. So that's pretty much it for load balancing. And if you want to know a little, to go deeper on load balancing, and especially on the third-party vendor, the partnership we do with load balancer vendors, F5, Radware, Citrix, pretty much it for now. Then you can attend that session, but actually that session was done in San Francisco, but is not done in Barcelona. So if you want to follow that one, you can still watch it, but online. And if you have specific questions, I stay here at the end. Okay? On the partnership and how we integrate with third-party load balancer vendors. Okay. All good on the load balancing? The last one is VPN. 15 minutes. Okay, so VPN. So we support two kinds of VPNs. I mean, like, or there are two kinds of VPNs, and we support them both. The SSL VPN, where you're in the hotel and you want to access your corporate things. And so on SSL VPN, you get your tunnel. Or we support site to site, so branch office to data center. The typical case, branch office to data center, and IPsec between the two. And magically, the branch offices have access to resources in the data center. So nothing new there. We support them both. Here you need obviously NSX, and we give you a client, an SSL VPN client. And we support Windows, 7, 8, macOS, Linux. We support different kind of encryptions. Obviously, higher is the encryption, lower is the throughput. That's true for everybody. In the site-to-site, you must have NSX here or here, but you don't need NSX on both ways. So you could have NSX, for instance, in the data center, and the Cisco you love or the Juniper you love to do the IPsec between the two. Myself, I love them all, so I'm good with whatever you have. And in terms of performance, each VPN you can do slightly over 2 gig, but to achieve that number, you need on your host, on the ESXi, you need a CPU with AES-NI, so that offloads compute from the VM to the CPU itself. So we go higher in terms of throughput. Okay? Now, if you don't have that on your ESXi, first you have a very old ESXi, but sometimes that happens. Still works perfectly, but of course the throughput will be lower. Okay? And we have a new one. We have L2 VPN. So that's for a specific use case. It's you have stuff in your data center. No, the other one. You have stuff in your data center in a VLAN or VXLAN, whatever. I didn't explain what is VXLAN. We can talk about that offline. That's the basic of NSX. But you have a subnet in your data center, and you have another subnet remote, and it could be in a branch office, it could be vCloud Air, could be anything, but you want L2 connectivity between the two. So the subnet here is the same as the subnet there. And you want this L2, magic L2 stretching between the two. And we do support that as well. So you need NSX on that side. You actually don't need NSX on that side. What you need is the ability to deploy a VM on that side. And that VM will be controlled by NSX on that side. And the tunnel will be, the tunnel will be magically, or there is no magic here. The tunnel, the VPN tunnel will be created between the two. Okay? So you don't need NSX actually on the other side. You just need NSX on that side. Make sense? All good? Okay. So that's pretty much, that ends the advanced services I wanted to talk about. Now I just wanted to finish with one thing, which is actually important. You should not consider NSX as a product. It's more a platform. So inside this platform, you have some network and security capabilities, and natively, and that's cool. But maybe we're missing something. There is a network service you want or security service you want, and we don't have it natively. I'll give you an example. We do firewalling with actually a pretty cool distributed firewall with amazing scale. with amazing agility. You remember the video I made where magically, or not magically, you know the trick now, but NSX knows about the new VM Linux, and automatically it will give the VM Linux the security you want for your VM type Linux, and in a fully automated way. So we do some pretty cool stuff you most likely cannot do today in your environment on firewalling. But maybe you want to do some IDP stuff. I don't do it. So that does not mean you cannot use NSX. And just because we don't have this little feature XYZ, then, oh, too bad, and you cannot enjoy any of the NSX benefits. What we do, because we are a platform and not a product, we have a bunch of plugins, and today we have a bunch of plugins, but this ecosystem with vendors specialized in this or that area can build their plugin and we could have, or we will have in the future, an even bigger ecosystem to enhance the network and security capabilities we have. Or I'll give you another example, like so Palo Alto Networks, they do some pretty cool stuff on layer 7. We don't do any. We stop at layer 4. So that will enhance the NSX system. The configuration will still be from NSX. You don't really touch Palo Alto Networks per se. So it's still centralized through NSX, but for the advanced things we don't do natively, actually NSX will talk in the back end to Palo Alto Networks to offer those layer 7 things we do not do. Now, maybe that stuff we do natively, but you still love your F5. And you can use F5 for load balancing. So you configure your load balancer in NSX, like the demo I did, but actually the pool and the VIP configuration is pushed in the back end to an F5 device, okay? So again, so important, it's a platform, it's not a product. And so here's a list of partners we have, and if you come next year, you'll see that list again, but other stickers on it, I'm pretty sure. So on the security part, I talked about Palo Alto Networks, but we have McAfee, Symantec, Trend, Rapid7. On the load balancer side, we have F5, Radware, Citrix. They are not all GA, actually, to be fully honest. But they can run POC, and we can do that in POC, show you in POC what we have waiting for the GA of this integration. On the operation side, we haven't talked about operation, but that's pretty important to know what's going on your network. And we have a partnership to enhance the operation capabilities of NSX we offer natively. So Riverbed, EMC, Gigamon are partners. And I'll just finish with a quick demo with Symantec. I could have selected another one, but I like this one. Shows the power you can have with NSX and partners to enhance what we do natively. So Symantec, you know, they do scanning to be sure you don't have any virus, and it's not new for Symantec. They have the ability to scan VMs, not with an agent inside the VM, but with an agent in the ESX. So that means it's easier to maintain because you don't have to update the new version of Symantec on all the hosts. And it's also more secure because if you have a virus, the first thing they will do is they will turn off any security device or agent you have on your host, on your VM, on your operating system. So more secure and easier for management. So they had that for a while. But so what is integration with NSX? So the Symantec agent running on ESX, not on the VM, does scan all the time the VMs on the ESX. And let's say it detects 2 VMs with a virus. So what it does, with the NSX plugin, so with the Symantec plugin of for NSX, it will tell, actually not NSX, to be fully honest, it will tell vCenter those VMs are infected. How does Symantec tells vCenter? You may not know, you may know that on vCenter for a while, you have the ability to put tags on a VM. Manually, you can add tags on your VMs. And that's what Symantec is doing, actually. It will tag those two VMs, so it will tell vCenter, please tag, or I don't know if it says please, but tag those two VMs with this tag. Okay? So now vCenter knows those VMs have the tag antivirus, virus found, L2 isolated network. And what vCenter will tell to NSX is those tags. So vCenter will tell NSX, those two VMs have this tag. And what you configured on NSX, remember the security group with dynamic membership? So you have a security group on NSX, which is called quarantine. And who do you have in that security group? All the VMs with that tag. VMs without that tag are not in that security group. And a VM can be in multiple security groups. So in the quarantine security group, you have no VMs. And now those two VMs have that tag. vCenter tells NSX. NSX put them in that security group. And what policy do you have in that security group? Accept nothing. Nothing can go out. Nothing can go in those VMs. OK? So as soon as you have a VM in that group, it cannot talk and receive any packet. Send any packet and receive any packet. And doing that, the VM is out of the network. OK? Cannot do any harm outside. And then Symantec has a feature, which is it will try to clean up the virus. And if it does succeed, then what it does is it will clean up, remove the tag. So it will tell vCenter, remove the tag of those VMs. vCenter will tell NSX, those VMs don't have the tag anymore. NSX will remove those two VMs from the current quarantine group. And now those VMs can do the stuff they could do before. OK? That's what the integration NSX plus Symantec does under the cover. So if you, then it's not the most impressive video. Oh, by the way, if you go to YouTube, blah, blah, you have the configuration piece, but it's like 10 minutes video. So I just show you the results. If you want to look at how you configure that, you go there. So the configuration is done. So you have the Symantec plugin installed on NSX. You have your quarantine group created on NSX. And on that VM, which is not infected, you ping something in the same subnet, another VM in the same subnet, and you keep it running. Then you launch that, the quality is pretty bad, you launch that virus, and Symantec will detect it, will add the tag, vCenter will tell NSX, and you can see automatically the ping stopped. And I stop here because if the configuration of Symantec is actually to not clean up, because if you do the test, it goes too fast and you lose no ping. Because Symantec will add the tag, will clean up, remove the tag, and you may lose a ping or nothing because it goes too fast. So in this video, the Symantec configuration is without removing. So you can see quarantine, you have the VM, you can see the policy you have, which is talk to nobody. And why that VM is in the quarantine group, it's because of that tag. And who added that tag? It's Symantec itself. So all that happened with no human intervention. Make sense? So yeah, 2 minutes, 5 minutes. But actually, I'm done, so you won't finish late. If you want to play with it, NSX, you have a lab. Actually, oops, I forgot to, I did update, but it did not update here. It's 1403, because we are in 2014 and not 2013. So this lab has been enhanced with new capabilities we have with NSX 6.1. So do that lab 1403. And you can see all the cool stuff we can do on firewalling, load balancing. And when you leave, if you can remember only one thing, of 3 things. So NSX offers natively all the network and security services you need for all your applications. Now we can do that natively, and we can enhance those with partners if you want to as well. Okay? No questions? No.